Okay, for those of you who missed the second day of Chapter 19 notes, we're going to run through this second hypothesis test just to go through the steps again and to look at what happens when we have a two-tailed test. So we have this situation where an educational organization, monitoring organization, collects data for public education, and they use 1996 numbers as a baseline, so it's sort of a status quo to assess changes. In 1996, 30% of the students reported that their mothers had graduated from college. So we're going to think of that as what everything's based on, sort of the status quo. So there's our claim for the population parameter. So the proportion of successful mothers graduating from college is 30%. In 2000, they took a sample of 8,368 students, that's found that this figure had grown to 32%. Okay, so that's a p-hat. So based on a sample, there looked to be a little bit of a change. That may or may not be significant. That's only 2% more. But we want to know if that gives us evidence of a change. Change is non-directional. Non-directional means it could have fallen, less mothers graduating from college, or it could be greater than, which is better written as a not equal to, or more simply written as a not equal to. So we want to see if we can find evidence that the percentage now is not equal to what it was back in 1996. Now all we have is one sample, but we're really after the truth about the entire population, and we're using this one sample to decide if we believe that 30% or not. So step one is to write our hypotheses. And we always start by defining our parameter. What are we measuring? And we write it out. So P for the whole population is the percent of students whose moms are college grads. Before you ever write your hypotheses, you nail down what your parameter is, otherwise you're not going to have a focus the rest of the problem. Once we have that done, then we write our null hypothesis, H naught, which is status quo. Nothing has changed. So the percentage of students whose moms have graduated college is still equal to 30%. So you could say 0.30 or 0.3. The alternative hypothesis is what we're really looking for evidence of, and that's evidence of a change. A change means that that population parameter is no longer 30%. Note that these numbers are always the same. The null is always an equal to. The alternative is always less than, greater than, or not equal to. These are pretty standard. We never stray from that structure. All right, step one's done. We just earned one of our 4 points on the AP exam. Let's go get the other 3. Step 2 is determining a model, and in order to determine a model, we have to check conditions. The only model we have is the normal, so we want to know if we can use a normal model or not. And there are 3 conditions we have to check, the first of which being randomness. In the stem of the problem, it didn't say that the 8,368 students were randomly selected. We don't know that. So the best we can do is assume that they're a representative sample. We don't know for sure, so an assumption is as good as we've got. So we'll assume that the 8,368 students sampled are representative of all students. No reason for me to doubt that. I don't know otherwise, so I'm going to go with that for the time being. Second condition is a sample size. Well, 8,300 students is a lot of students, but there are a lot of students in the nation. Nationwide, we certainly have more than 83,000 students, past, present, and future. So it makes sense to say that 8,368 students is less than 10% of all students nationwide. that's definitely believable. All right, then the NP and NQ. Out of the 8,368 students, in a perfect world, if the null is really true, which is our assumption, 30% of those would have mothers who graduated college, would be considered successes. So 30% of 8,368 is 2,510.4. NQ is 8,368 students, and the other 70% of those, in a perfect world, if the null was true, would not have mothers who graduated from college. So that would be the other 5,857.6 mothers. Those are both at least 10. Far more than 10, so securely feel that we have a normal model for our sampling distribution. And so since a normal model is appropriate, we will use a 1 proportion z-test. It's a 1 proportion test because we only have one sample p hat. All right, we've now earned 2 of our 4 points for a hypothesis test on the AP exam. Let's go for point number 3. Number 3 is the mechanics. I like to start with a picture of how everything is related. So if this is the picture of all possible samples of size 8,368 and the corresponding percent of kids with moms who are college grads, p hat, we assumed that 30% of those were successes, so that should be the mean. And the sample was 32%. So I'm going to just go ahead and skip to a z-score. It's going to do 2 things. It's going to save me time to skip to writing the z-score, and I'm not going to have to keep up with confusing and easy to mess up notation. So I'm just going to put it all in one step. My sample proportion was 32%. In the one sample we looked at, 32% had college grad moms. We were expecting that number to be 30% if there was really no change. So observed minus expected over the standard deviation. Standard deviation we have a formula for. It's the square root of PQ over N. If we know the true P, we should always use it. So we never use P hat and Q hat here if we know a true P. And we're assuming that our true population proportion is 30% successes, 70% failures. So always use the true P over the sample size of 8,368. And so in this one step, I've shown that I know my sample p hat, my population assumed p, and how to calculate the standard deviation of p hat. So all my mechanics are really rolled into one step right here. And if I crunch those numbers, I'm going to end up with a z-score of about 3.99. So I'm nearly 4 standard deviations out from the mean. So I'm way the heck up there. 1, 2, 3, 4. I'm looking at a little area about here. Teeny tiny proportion of all possible samples falls there. So this is a very unusual sample. It would be very difficult to pull that sample if in fact 30% is the truth. So I'm not buying it. I think I've got some strong evidence here that 30% is no longer the true proportion of students whose moms are college grads. That probability of getting a z-score at least 3.99 is pretty large. It's like 3.3 times 10 to the negative 5th. But there's a catch here. Even though this sample is above the mean and very small, if I look back at my hypotheses, I had a not equal to, which means if I'd pulled a sample much bigger or much smaller than 30%, either one of those would have caused me to reject the null. So what I want to do that's different in this case is know that this is a two-tailed test, which means if I had been 4 standard deviations below the mean, then I would have been equally surprised at the result. So when I find the area under the curve up here above 3.99, I also have to consider the matching area below negative 3.99, which means I'm going to have to double this probability. So I'm going to multiply it by 2 from the beginning. So when I put it in the calculator and calculate my normal CDF, I want to make sure I double it before I write it down. And so that's going to give me something in the neighborhood of 6.6 times 10 to the negative fifth. Very close to 0, so very unusual to get anything in either of those two tails. The only difference in a one-tailed test and a two-tailed test is in a two-tailed test we have to consider the possibility of being too big or too small. So we double the probability of getting that z-score. That is the only mechanics difference. You could also rewrite this in decimal form if you so choose. You don't need to. This works just fine on the AP exam. This works just fine on the AP exam. Do not hand them an E-5. Calculator speak does not work. You don't get to speak calculator language, only the calculator does. So let's wrap this up with a conclusion. So after we find their p-value, we want to link that p-value to a decision about the null. I don't believe the null is true because my evidence points to the fact that it's not 30% anymore. So I'm going to say with a p-value of 6.6 times 10 to the negative fifth, that's very close to 0, I will reject the null hypothesis. I just don't believe it anymore. If I reject the null, then that leads me to believe that the alternative must really be the truth. So I have strong evidence, because it's really close to 0, so that's really strong evidence of something interesting going on. I have strong evidence that that's not the word that the true proportion of students whose mothers are college graduates are at I've lost my train of thought. Whose mothers are college graduates are I can't think. I have strong evidence that the true proportion of students whose mothers are college graduates is not 30%. So I believe there's been a change. Okay. So day 2 homework, from page 513, we did problems 15 and 23. And then on day 3, we didn't do any new notes. We just did extra practice. From page 512, I believe, is where it started. 11, 25, 29, and 33. All right, we have a quiz on Monday. Had a quiz on Monday. And those of you who are out, we'll schedule a makeup when you get back.